So for example 2, it is find the derivative using the definition, which is the limit definition of a derivative, which we found up here, of f of x equals 4x cubed plus 3x squared plus 1. First thing I like to do when I'm doing a question like this is I like to rewrite the limit definition of a derivative. It helps me keep track of where to plug things in and how to do this problem, but also memorize this definition. So here is the limit definition of a derivative. I like to break it down into 3 parts. After I write the limit as h approaches 0, I'm going to have to write this part I put in a blue box. Then I'm going to have to write this part I put in a green box. And then I'm going to have to write all over h. So start with the limit as h approaches 0. Now I'm going to do f of x plus h. So I'm going to have to plug that quantity x plus h in for x twice because there are 2 x's in this equation. 4x plus h cubed plus 3x plus h squared plus 1. Then it's a minus. Then I have to do f of x, which is just copying the equation as is. Then I'm going to do the purple part, which is just write h. What you do when you're doing a limit definition of a derivative is you're finding the slope of the tangent if you have a given point. Here we don't have a given point, so we are just going to be finding basically like a formula to find the slope of the tangent at any given point. So we will have an x in our answer. And what we have done at this point is just created ourselves a limit problem. Just like we learned in chapter 1, now we have to actually solve a limit problem that we wrote ourselves. So the strategy we're going to use here is simplify, which means we need to get rid of all the parentheses, combine the terms, cancel out anything that we can, and then plug in 0 for each. So the first thing I run into is this x plus h cubed. I'm going to use the binomial theorem, which we learned last year, to expand this binomial. Start with the third row of Pascal's triangle, 1, 3, 3, 1. And then it's x cubed, x squared, x. And back the other way, h cubed, h squared, h. And then that is expanded. Then I'm going to use the binomial theorem to expand x plus h squared. So second row Pascal's triangle is 1, 2, 1. Then it'd be x squared x, and then h squared h. Got that, and then I have my plus 1, and then I'm just going to have to distribute the minus to the green terms to get those good. All right. Next, I'll distribute the 4 to all 4 terms. I'll distribute the 3 to all 3 terms, and then I'll see where that gets me. So the limit is h approaches 0 of 4x cubed plus 12x squared h plus 12x h squared plus 4h cubed plus 3x squared plus 6xh plus 3h squared plus 1 minus 4x cubed minus 3x squared minus 1 all over h. Then we'll cross out whatever we can cross out. Looks like we've got a 4x cubed and a negative 4x cubed, a 1 and a negative 1, and a 3x squared and a negative 3x squared. Right. The remaining terms, what I'm looking for here is, do they have any common factors that I could take out? And they do have, many of them have a factor of 3 or 4, but not all of them. Lots of them have an h, or an x, but not all of them, but they do all have an h. So I'm going to factor out an h next. The limit is h approaches 0 of h times quantity 12x squared plus 12xh plus 4h squared plus 6x plus 3h all over h. And then I'll cancel all those h's. All right, now what I have left is just this, and at this point I'm able to plug in 0 for h. So 12x squared plus 12x times 0 plus 4 times 0 squared plus 6x plus 3 times 0. So it looks like my final answer is going to be 12x squared plus 6x.